I'm Ahmad, and I'll be presenting today for DistAYA. And first of all, thank you to the Kohe for team for arranging this AYA expedition and all of our collaborators. So I'll talk first about the problem statement. So as we know that large language models have many deployment challenges, and these are autoregressive models. So as the number of tokens are increasing, uh, the memory requirements and the latest latency requirements are also increasing, which makes it difficult to deploy, especially on the edge devices. So the goal of this project is that we wanted to create multilingual language models that not only match the power of large multilingual models, but also are being more compact and can run on edge devices. So we wanted to retain the linguistic diversity of IR238B while significantly reducing the size for real-world applications. Next slide, please. So we considered five potential techniques to reduce the size of IR models. So the first technique is pruning, which can be further divided into three parts: unstructured pruning, structured pruning, and semi-structured pruning. Then the second technique is knowledge distillation, in which we have a student and teacher model. Then there is quantization, which can be further divided into two parts. So quantization aware training and post-training quantization, then low-rank factorization and fine-tuning as well. Next slide, please. So the first technique that we used was sparse GPT. Sparse GPT was introduced in this paper. Massive language models can be accurately pruned in one shot. And sparse GPT helps us enable 50% pruning of large language models without retaining by using a layer-wise approach. And the IR model, we uniformly pruned IR model in all linear layers, excluding the embedding and the head, as standard to 50% unstructured sparsity, as you can see in the um, second bar in the bar plot. So the first bar is the dense IR23B model. The second is the uniform sparsity model, which has 50% unstructured sparsity. Then we have 2:4 sparse model, which uses semi-structured pattern of n:(m) sparsity format. And there are two forms with stringent and partial sparsity, when one must choose a subset of layer to n:(m) sparsity. And you can read the paper for more details. And the last technique here is the joint sparsity and quantization, in which we combine the sparsification and quantization, which would allow combining computational speed up from sparsity with memory saving from quantization. And we can see that there is a perplexity, the perplexity scores is increasing as we move forward. Next slide, please. Then we have short GPT technique, which was introduced in layers in large language models are more redundant than you expect. In this technique, we explored the number of layers which are not important in the IR model. And we found, we calculated these number of layers which would have the smallest effect on KLD loss or DI block interest metric. And we found that layer 3, 6, and layer number 10 are the layers that have smallest effect on KLD when these are removed. And we can see in the metrics, in the evaluation metrics on the right side, that the MMLU for English language for the base I model value has a value of 0.45, whereas with pruning, the value drops to 0.22. Due to compute constraints, we were only able to run the evaluation for English language. Next slide, please. Then the next technique is hidden state-based distillation, which is the distill kit that is basically that allows us to perform task-aware layer-wise distillation. And in this case, we used IR238B as a teacher model and Quen27B as the student model. And we can see that as the distillation steps are increasing, the value of MMLU is also decreasing. But in this case, the student model that we were using, which is 227B, is already stronger student model than the teacher model. So, and we were not able to run the evaluations on all of our evaluations, but we plan to do the compute constraint, but we plan to continue further on this experiment. Next slide, please. And the last technique that we explored is fine tuning, in which we use 20 1.5 B model, base model, and we constructed a data set that has 540,000 rows, and it consists of 5 different languages. It consists of Bangla, English, Urdu, Arabic, and French. And we fine tune this model end to end for one epoch on 20 1.5 B, and we can see the graph for loss values in the right side. We have not run the evaluations on it yet due to next slide, please. And this is a work in progress. We plan to continue our experiments, and these are some of the future works that we would like to explore for this trial. Next slide, please. Thank you very much. And our codes and data sets are all available on Hugging Face, and you can see them on this link that we are